Well, you guys, you made it to the end. This is the last video of the semester. So, good news is we are done after this. I might make some review videos. I haven't decided yet. Depends on what you guys want. But for lessons, this is it. So, real quick, all this is really a summary with one application. Okay, so if I give you a polynomial function, all of these statements are the same. Okay, when I say k is a zero of a polynomial, that's called the zero. That means that it is a solution. Hence, down here, solution. K is a solution of the polynomial equation f of x equals 0. K is 0 means when you plug it in, you get 0 out. K is a root. Again, root means it's a 0. K is an x-intercept. Well, again, K is, assuming K is a real number, it is an x-intercept of the graph when it crosses, when y is 0. Because that's all these mean the same thing. And then finally, when you see x minus k, that's a factor when it's a solution. So when you factor it, that's where we get our zeros from. Turning points are local mins and maxes. You can just see those on the graph. Pretty much, if it's to the third power, it has at most one less turning point. So 2 turning points for a cubed. So if it's like x cubed and it goes like this, it turned once, it turned twice. There's a turning point, here's a turning point. Sometimes it's less than that because it depends on how many real zeros there are. But you could always look at the graph for that. So that's not a big deal. You should be able to see that on the graph. Alright, let's look at the application problem. You want to make a rectangular box that is x centimeters high, x plus 5 centimeters long, and 10 minus x centimeters wide. What is the greatest volume possible? What are the dimensions of the box? B to the nearest tenth. Well, first of all, you guys need to know what volume is. Hopefully, for a box, you realize that it is width, length, and height multiplied together. Okay, now, do you need to multiply all that out? No, you do not. We're using the calculator for this one. So, let's go right to the calculator for this equation. Okay, once you have your equation in the graphing calculator, you hit graph. And you can't really see a lot there. Don't know what's going on there. There was a line over here. It looks like it went down, up, down. Let's zoom out a bit, because we can't really see what's going on. Just to help us out a bit. Okay, still can't really see what's going on. It looks like it went down, up, and down. I'm going to trace to see what's going on. So I'm at y equals 0. As I go to the right, it went up a bit. It went up really high. So y is all the way up at 180, 200, 250. Okay, so as I trace this, I'm going to make my window a lot different. I'm going to say my x is negative 5 to 10, because I want my x to be small, left and right, and my y min to be negative 40 is fine, but let's make this 300. And just take a look at that. There we go. Okay, so now I can see everything. So the curve dips down below negative 40. In fact, you could have made your y min maybe negative 100, just to take a look at it. There it is. Okay, so there's the whole curve now. Alright, so, but we're talking about a real life problem. So, we probably don't want a negative x for our answer, because that would make sense. You can't have a negative side length of a box. So, our answer is going to fall within this range. Hopefully you guys can tell me. Remember, this curve represents the volume of the box depending on what your x value is. So, hopefully you guys could tell me that the volume is maximum at this point up here at the maximum. So let's find out what that is. Second trace, 4 for maximum. And I'm going to move over, hit enter, and move over again, and hit enter. And I'm going to hit enter in the middle. And you get 6.076 and 264.07. It does say on the problem to round to the nearest tenth of a centimeter. So it's 6.1 and 264.1. So when I graph this, and I'm going to just sketch to show, so if I give you a problem like this where you have to show work, basically I just need to see a sketch, and I need to see the point that you picked, and this is 6.1 comma 264.1. So it says, what is the greatest volume possible? V max, or the greatest volume, is 264.1 cubic centimeters. And what are the dimensions of the box to the nearest tenth? Well, x equals 6.1. So that means my dimensions are 6.1 by 6.1 plus 5 is 11.1. All I'm doing is plugging the x into each of these. So 6.1, put a 6.1 there, and 10 minus 6.1 there is a 3.9. So that is the dimensions of the box that will maximize the volume. So we use polynomial function to design this box, depending on what kind of pre-existing thing we needed. Like we had these constraints. So, all right. So that's the new thing. This is a review problem number 2, except for it's kind of crazy. When you see something like this for the function, all this is saying is this is already factored out. So I already did a little bit of work for you. I pulled this already out of there. So we already have this part factored, and you can get your zeros from that. So we need to now factor this. Okay? What you can do to factor that is just put this polynomial in. Not for the final graph. So when you do sketch the graph and describe end behavior, you want to graph the whole thing. However, to find the zero of this, to fix it, and it really doesn't matter which one you do actually, but let's plug in let's plug in the whole thing, just because we have to keep it in there anyway. So let's do that in our calculator. Plug the whole thing in. Alright, when you graph the whole thing, and again, if you want to see what I put in for y equals, that is what I put in. I had the first parentheses and then the second one. You get this. Now, the curve goes way up here, comes back down, and then back up. So I want to look at up here more, so I'm going to change my window so that my y max goes pretty high, and you can trace to kind of see how high it goes, but I'm going to say 150 to see if that works. So I just changed my y max to 150. Now I can see my full graph. Okay. Now I need to find a zero out of this so I could factor it. Second trace 5. Now I already know what it's going to be, but I just want to show you the steps. I'm going to try this one right here. It's not 0.3. That won't work. So let's move over one to this one. 1. Okay, that's the one that's going to work, which means the other one's not going to work. So we got 1. So let's go back to our problem. And I know that one of my zeros here is x equals 1. So factor completely. So I'm going to factor this completely some more by synthetically dividing that piece only. I don't need to do anything with this piece. It's already factored out. I'm just trying to factor this one now. Okay. So I bring down the 1. 1 times 1 is 1. Bring down that, which is 3. 3 times 1 is 3. Bring down that. That's a negative 1. And we get negative 1 is a 0. So that is correct. So for part A. So this is part A. I'll work across here. So the answer to part A is the completely factored form for this polynomial is we have the x squared plus 9 out already. We have now, because I divided by 1, it's x minus 1. And what I got out of this is x squared plus 3x minus 1. Okay? Now, I know this is not factorable. The reason why I know this is not factorable, this piece, is because when I looked at my graph earlier and I found that other point, it was not a nice point, which means that there has to be a piece, the quadratic piece, that does not give me a nice point. So, I have A's. So now I have to do part B. Find all the zeros. Alright, well this is pretty easy. I set each piece equal to 0. X squared plus 9 is equal to 0. X squared is equal to negative 9. X is equal to, when you take the square root, plus or minus 3i. There's 2 of my zeros. X minus 1 equals 0. X equals 1. We already found that one earlier. This one, I have to use quadratic formula. x equals opposite b, plus or minus the square root, b squared, which is 9, minus 4 times 1 times negative 1, all over 2 times 1. Now, I knew this would end up being a real number because those hit the graph, so it'll just be not a nice real number. 9 plus 4 is square root of 13 over 2. Here are the other two. We can't simplify that any further. So we have two imaginary that don't show up, that we couldn't find, that one nice one, and then these two real that are not nice. And I have all my zeros. So now it says sketch including, and this is where you include all of your important information. Okay, now since you have the zeros, you don't have to do anything for the zeros anymore. The only thing you need to find are the max, the min, and the y-intercept. So let's do that real quickly. Alright, so remember the y-intercept, just go to the table to look for that. So the y-intercept is when x is 0. The y-intercept is 9. So I have the point 0, 9. Now I'm going to look at the max and the min. Second trace, I want to find the max first on the left. I have to be all the way to the left of that point. Alright, stop. This calculator does not work for me sometimes. There it is, okay. Nope. Well, anyway, hold on. You guys already probably have it done already, so there we go. Technology sometimes very frustrating. Alright, here we go. So, my maximum is negative 2.310 when you round to 3 decimals and 123.087. Okay, so I'm going to write that down right now. So I have the sketch, which kind of looks like this. And again, it just has to be, generally the sketch. This maximum is that negative 2.310 and the 123.087. We have this y-intercept at 0, 9. We did that on the table. Now, we could also put in our zeros. And here's the nice thing. You don't have to give me the decimals. We have the zeros here. We know this one was x equals 1. We found that one. This is 1, 0. Now, here's the thing you can do, and I'm going to talk about this in class today. We have two other zeros. They're right here. Negative 3 minus root 13 over 2 and negative 3 plus root 13 over 2. Well, the smaller or the more negative number will be this one over here. So this 0 is negative 3 minus root 13 over 2, 0. That's the exact 0 there. You don't have to do anything else. You already found it. You can check your answer if you want. This 0 is negative 3 plus root 13 over 2, 0. And again, we already found them. You don't have to type it in and get a decimal for me. You can just leave it as exact. In fact, I would prefer that shows you that you understand what you just did here, that you found these. Alright, and then the last thing we need to do is find the min. Hopefully you guys know how to do that. I'm going to just show you what it is. If you do the minimum, you should get 0.675, comma, negative 4.550. Alright, so that is all the important information that you need when you sketch a graph. And then, so this is part C. And then part D is the end behavior. Alright, remember the notation. As x goes to infinity and as x goes to negative infinity. So as x goes to the right, what is the function doing? Well, as we go to the right, the function's going up. So it's going in the positive infinity direction in the y. As x goes down to the left, the function's going down in the negative direction. So that is your end behavior. Okay? Alright, I know there was only 2 problems, but I know this was a little bit, I don't know where I got cut off there, but anyway, like I was saying, it was a little longer, but again, this is a good problem to go through because it shows you everything we pretty much did with these things. So, hope you guys enjoyed the videos. Get ready for final exams and the test, obviously. So, I will see you guys later.